Hi all, in this video we are going to see a new data structure, nothing but queue. What is queue? We have seen this word frequently. That is, if I am going to a movie theater to buy a ticket, we will be standing in the queue. So that is the strategy we are using in this data structure. Those who are entering the first is going to come out first. So this is the concept we are going to see in this queue data structure. So queue is nothing but a data structure which comes under linear. So it is a linear data structure which is opened at the both the ends. Okay, queue is nothing but it is going to be opened at both the ends. Okay, so here in this data structure, we are going to use first in first out strategy. That is, those who are entering into the queue first is going to go out. So entering is going to be at one end and removing is going to be at the other end. In queue, insertion of element are made at one end and deletion are made at the other end. Okay, this queue is having two variable, one is front and rear. So if I'm keeping this as a front pointer, then the deletion, sorry, if I'm keeping this as a front pointer, the deletion or going out is going to happen at this end. Then rear is the position or pointer in which insertion is going to happen. So front is the index where the element are deleted from the queue, and rear is the index where the element are inserted into the queue. So this is all about queue data structure. Okay, queue is a linear data structure which is going to have first in first out strategy. Okay, insertion and deletion is going to happening at the respective ends. Okay, here we are having two variable, front and rear. Front is the index where deletion is going to happen, and rear is the index where we are going to insert the element or enter the element. Okay, what is the characteristic of the queue? So this using a queue data structure will help us to handle the multiple data. So we can access both the ends, and it is more fast and flexible to use in our application. So what are the some of application where this queue data structure can be implemented? Okay, as I told you, the most characteristic is it is going to be both the end is going to be open. So multiple operation I can do. So multi-programming. Okay, most probably we are going to use this queue data structure in the networks and in operating systems like job scheduling, shared resources. These are some of the operation which is performed in the operating system. Okay, some of the real-time application are ATM booth line, ticker counter line, key press sequence on the keyboard. So this is the frequent one. That is, if we are pressing multiple keywords in our keypad, then first entered key is displayed in the screen first. Correct? So here also we are using the queue data structure. CPU task scheduling. It is nothing but multiple tasks. That is, if we are typing or if we are moving the cursor, then if we are switching off, it is going to be stored in the queue, and each and everything, the first process is going to done the first. So first in, first out. Okay, then waiting time of each customer at the call center. Okay, there will be multiple calls at a time we can make. Correct? Multiple person can call at a particular center, so they will be waiting. It is where we are using the queue data structure. So what are the operation you can perform in this queue data structure? So enqueue is the function where we are inserting the element into the queue. Dequeue is another function where we are going to delete the element from the queue. We call front, which is going to return the front node of the queue without deleting it. Okay, rear is going to return the last element without removing it. Okay, is full and is null is going to tell me whether the queue is full or not. If a queue is empty, it is going to be null. So these are the basic operation I can perform using queue. As we have seen, the one data structure is going to be combined with other data structure. Okay, so this queue can be implemented with two data structures, that is nothing but array and linked list. If I'm using array, then that queue is going to have fixed size. If I'm using linked list, the size it is we are not going to fix any size if I'm using the linked list data structure in the queue. So what are the advantages of a queue data structure? Large amount of data can be managed efficiently. Operation like insertion and deletion can be performed very easily. Okay, the particular service can be performed for multiple consumers. It is going to be very fast in the IPC, inter-process communication. It is one of the operations that is performed in operating system. Then it is implemented use this data structure can be used with other data structure. That is, I can combine two or more data structure to perform one particular operation. Now let's see what are the disadvantages of the queue. The operation like insertion and deletion in the middle is very difficult if I'm using queue data structure. Okay, then space is going to be limited. Then queue, if I'm going to insert a new element and the existing element is deleted, then it is going to be empty. Searching of element is going to be order of n. Maximum size of a queue must be defined prior. So these are the disadvantages of queue. I hope you would have got some idea about what is queue data structure and what are the operations. Thank you.